Okay, I think we'll go ahead and get started. Good afternoon. My name is Mike Warlick. I'm Vice President for Defense for AFCEA International. I want to welcome you to the Marine Corps Theater. We've had a couple great presentations today, and we've got a number that are left. We've got one more this afternoon. Tomorrow morning, we've got one on data. It's a panel that I think you'll really enjoy. It's a combination industry and government. Greg Garcia, the Army data and Deputy CIO will be a part of that panel. And then we'll have some MCTSSA sessions going also. So for those of you in industry, you probably want to pay attention in particular to the MCTSSA sessions because there's a lot to offer you as an opportunity. Okay, our next speaker this afternoon is Major Ryan Ackland, obviously USMC. He works at MCTSSA, Marine Corps Tactical Systems Support Activity. He's an aviation command and control officer and a recent graduate of the MS Computer Science curriculum at Naval Postgraduate School. Virtually all the senior staff and junior level staff at MCTSSA are graduates of MPS. So that's you've got technology working to your advantage while they're there. He's completed 2 operational tours, including an overseas tour in Okinawa, Japan, and operational Enduring Freedom back in 2014. He's a graduate of the Basic School, honor graduate at Air Defense Control Officers Course, Weapons and Tactics Instructor course. He's also attended Expeditionary Warfare School and recently completed Naval War College. A lot of these officers at MCTSSA are taking senior level college by correspondence, and they're getting ahead of the game. Some will get invited to that senior level school, others have already got it done. They don't need it for their career path and they continue on. Today, Major Ackland will discuss the systematic testing approach taken by the Naval Integration Team that developed and implemented an end-to-end C5I shipboard systems operational or operability test that's now a standard pre-deployment evolution for MEUs and embarked special MAGTFs. So he's going to talk about a process that they developed. They're using it, and I think you'll get a good idea from his presentation how important it is. Over to you.
Good afternoon, ladies and gentlemen. Thank you for the warm introduction, and thank you all for attending the session. I know it's late in the afternoon. I'm blocked for an hour, but I will not go the entire time. So I will brief fairly quickly, and at the end I'll take some questions. But he hit the nail on the head, but my purpose of being here is to discuss some of the work that the Naval Integration Team at MCTSSA is doing, to talk about some of the systemic challenges that we see for Marines working on ships, and then provide some opportunities for you all in industry on some of the work that we're doing at MCTSSA, and also to address some of the challenges that Marines face using their systems on ship. So next slide, please. This is my get out of jail free card for the brief. But joking aside, the work that we're doing is more relevant than ever. If you all have read the Commandant's Plan and Guidance, naval integration is one of his top priorities, and that was discussed this morning during the panel session. But the Marine Corps needs to be able to fight from the sea and integrate with their naval counterparts on the ship, especially to conduct sea control in an A280 environment for the future fight against a peer competitor. Next slide. So to provide an overview of what we do, we provide integration testing, system engineering expertise, and fleet technical support to USMC and U.S. Navy Afloat C4 systems. U.S. Navy is included on there because we have started to work for different Navy program offices, specifically IWS-10. They've adopted and outfitted a Marine Corps program of record onto a ship for F-35 integration. That's specifically CAC-2S Afloat. So our focus areas are operational readiness for deploying MEUs and embarked special purpose MAGTFs. I'll go into more in depth on our SOT process, but essentially we'll come on board and make sure that systems work and that the Marines and operators, maintainers that are using those systems know how to use them and know how to integrate them into the shipboard environment. We do that through validating mission-based capabilities for those deploying MEUs, so we will cater our event to their mission set and validate some of the capabilities that they're going to be deploying with. A recent focus area is JSF shipboard C5I integration. Now that the JSF is forward deployed, we need to be able to incorporate JSF integration for future deployments leading up to the deployment into the PTP cycle, and just ensure that we're leveraging the fifth generation sensor capabilities of F-35 into the shipboard C5I systems. We also have a MAGTF Afloat integration environment. As some of you may or may not be aware, it is a exact replica model of the USS Macon Island. So it's not just the LFOC, so I'm going to refrain from using that term, but it is all of the marine shipboard spaces, so the LFOC, SAC, TACLOG, and JIC spaces. And if you take a look at the facilities, it feels like you're on a ship. Not just the look and feel, it's got the flooring, all of the furniture, but also the network environment looks like you're on a ship. We do have an instantiation of canes, and we are looking to increase that capability to provide a more realistic network architecture for program offices and for deploying MEUs and embarked special purpose MAGTFs. Next slide, please. These are just, this isn't a comprehensive list, but these are just some of the people that we have been working with, from the sporting establishment for the Marine Corps, USMC program offices, and then a variety of offices in the Beltway, MCTSSA, CD&I, Headquarters Marine Corps C4, and then the operational test facilities, VMX-1, MCTSSA, and then similarly for the Navy, being close to NIWC PAC and NAVWAR, we work with a variety of the PMW program offices, specifically 160, 170, BISOG, and PMW 750 air and carrier integration. Recently, we've increased work with IWS 10, which is the program office for the ship self-defense system, the combat system, as well as CAC2S Afloat. And they also provide support to the SAC-A program, which is the fires systems in the SAC on ship. And then from the fleet, from the Marine Corps, from the smallest elements of the MEU and Special Purpose MAGTF all the way up to the MEFs and the FMFs, we're working with a variety of stakeholders, including the Marine Communication Detachments at the ESGs, who are soon to be called the Amphibious Communication Detachments. And then on the right side, same thing with the Navy, working down at the ESGs up to the numbered fleets and Surf Pack, Surf Lant, and Pack Fleet. So a variety of partnerships, not all inclusive, but we are working with as many stakeholders as we possibly can. Naval integration is a challenge, and part of the challenge is that there's so many stakeholders and so many stovepipes, and to integrate everyone that needs to be integrated is a real challenge for the naval service. Next slide. Okay, going into to more depth on some of the work that we've been doing. The biggest focus area is enhancing the readiness for MEUs and special purpose MAGTFs. And we've developed a systematic testing approach called System-of-Systems Operability Test, or SOT, and we actually have mirrored what the Navy is doing with the SOT process, which focuses on Navy programs of record, POC4I, and we have done the same thing with Marine Corps programs of record. And so we will go onto the ship, we will test out all the programs, the Marine programs of record into the shipboard environment, make sure that they work, that the Marines know how to use them, and that they can meet the mission requirements for that specific deployment. And so we work very closely with all the MEUs. We've done pretty much every single big deck, LHD, LHA, and we've also hit some of the smaller decks, LPDs, LSDs, and it continues to grow. So pretty much every deploying MEU and Special Purpose MAGTF or task force that's on a ship goes through a MCTSSA SOT to make sure that their systems work properly. Some of the other work that we've done is GCSS Marine Corps WAN optimization. GCSS Marine Corps is the Marine Corps' logistical command and control system, and it was not particularly designed for shipboard use. And so the past few years, there was a lot of issues with Marines being able to use GCSS Marine Corps on ship. It had the same prioritization level as just general network traffic like Facebook, and so it wasn't operational on the ship per se. And so what we've developed with several people at MCTSSA in conjunction with the GCSS Marine Corps Program Office and the Navy is to change the quality of service setting to optimize the use of GCSS Marine Corps on ships. And so that is now a standard thing. And so when we do our SOTs, we use a riverbed software to change the QoS settings of GCSS Marine Corps. GeekSem, not to confuse that to GCSS Marine Corps, GeekSem is a Global Command and Control System Maritime. That is what the Navy uses to pull in the common operational picture from higher headquarters. The Marine Corps plugs that into the LFOC to gain situational awareness to see the COP, and we've helped the Navy during our SOTs to help troubleshoot GeekSem. We work very close with PMW 150, and we've also helped out the CS2S Afloat Program Office to develop an engineering solution for GeekSem. For COP, leveraging virtualization, so not every deploying task force or MEU has all of the equipment that they need. For example, Special Purpose MAGTF Alaska, Task Force Oceania coming up, they don't have all of the equipment that they need. And so one of the things that we have been doing is virtualizing some of the C2 systems that these deployers use and using it into the network environment as virtual machines. And so one of the things that we have done is used JTCW and Tactical COP Server VMs to leverage that capability. So the Marines don't need to use their own, they don't need to acquire new equipment, and they don't need to bring it on if they don't need to. And so that's a huge capability we are conducting on ship, and we hope to expand that in the future. Validating operational mission threads. I kind of touched on that earlier. What we do on the ship is really directly attributable to the mission set of that particular MEU or Special Purpose MAGTF. And recently on USS America, we did some pretty exciting stuff for JSF. We validated quite a few different digital fires mission threads and into the C5I systems that you see below. So AFATDS, CS2S Afloat, and JDOCs. And so we're hoping to continue that work for other deploying MEUs that, with F-35. Next slide, please. Okay. So based on the work that we do on ships, we've identified several systemic issues that both the Navy and Marine Corps face on ship. The biggest one being training. The complexity of the systems that Marines use on the ship, the complexity of the networks, and just the overall reliance on contractors and civilian technical support, whether it be Microsoft or Lockheed Martin guys to manage the ALICE system. There is an over-reliance on contractors to use, maintain, and configure C4 systems on ship, and that is a big issue. The other big issue is a lack of a persistent C4 environment for Marines. When Marines go onto the ship, it's almost like they're the first Marines to ever go on ship ever. So they have to rebuild the networks from scratch. A lot of them not having any experience on ship or doing this, but they have to build the networks, build up all the enterprise services, and it's a challenge. And that's hopefully going to change pretty soon here with the amphibious communication detachments. Essentially, there are 100 Marines across the Marine Corps are going to go to the expeditionary strike groups and basically be assigned to ships. And hopefully, develop a persistent network environment. That way, whenever a MEU or a task force or whoever wants to deploy on the ship, they show up and the network's already there. So that's kind of the future goal, but right now it is it's a very steep learning curve for Marines going on a ship. They have to start from scratch, and going back to my first bullet point, be reliant on contractors and other civilians for technical support. The complexity and variety of the shipboard networks, that is also a big issue. So not every ship is the same. And actually, I take that back. No ship is the same as far as its network architecture. And all these issues are kind of tied together. But the Navy modernization process, if you have a new system that you want to deploy on a ship, it'll take, based on the availability schedule, it'll take 8 years to install that. Let's say it's just one piece of software. It'll take 8 years to be able to hit every single ship based on the availability. So that kind of compounds the issues and makes it very difficult to standardize anything and to basically improve the software, hardware on ship. So the different networks that we see, CANES, a variety of versions of CANES or ISNS or SWAN, all of these, there's no good instruction for Marines on how to use this or how to build the networks. And so going back to my last point, Marines will show up with a very complex network that they've never used before, that they've never seen, and they'll be reliant on external support to get it configured and built properly. Shared U.S. Navy USMC COP. So the way that the Navy receives the Common Operational Picture is from a higher numbered fleet agency or PAC fleet, COCOM, that is sending the COP via GeeksM. Well, unfortunately, at the highest level, whoever the top COP is, they are filtering the land tracks for the Marines. And so when Marines go in to pull the COP over GeeksM, all they see are surface tracks, which may or may not be, which are most likely not relevant to the Marines. And so that's an issue. It forces the Marine Corps to establish a separate channel to pull in from the Marine Corps FMF PAC or COCOM to get the actual land tracks. And so that's more of a policy issue that I've been driving, but it's an issue nonetheless. And so it requires extra equipment, extra manpower, extra red tape to unblock firewalls, et cetera, that the Marines have to deal with. We talked about the Navy modernization process. I think I could be here all day complaining about it, but it's more of a constraint than something that we can actually fix. We can't change the availability schedules; those are kind of set. So we have to work with inside of those constraints. And then the Navy certification process. Luckily, the Marine Corps does not have that challenge as much as the Navy does. There is a letter of reciprocity agreement so that Marine programs of record, if they have an ATO with the Marine Corps, they can plug it in to the USMC portion of the network. But for the Navy, it does take a couple years to actually integrate a new program of record into the network environment, and it's a very tough and complicated process. Another systematic process that is painful to all is the ship main process. Marines can't just go in and plug in a piece of software to something that's part of the ship and upgrade it. So like the shipboard AFATDS, you can't just go in and plug in the new piece of software. It's got to go through this long process. And there's a process for everything, and there's a dozen people that take 20 days to do things, and it's just ridiculous. And another example is anything that is on the ship, like a laptop. If it's going to be permanently on the ship, you have to spend like $1,000 to strap it down in a shock-proof case. When Marines have hundreds of laptops that are sitting right next to it that they deploy with. So it's just red tape bureaucracy that it could be improved. It's just a matter of refining some of these processes and getting rid of some of the bureaucracy. I'll step off my soapbox on I'm complaining if anything else, but they are legitimate challenges that Marines face on ship. And then interoperability requirements, as more and more technical systems become reliant on exchanging tactical data, so Link 16 VMF, they have to have the same level of requirements to be interoperable. Not every C2 platform that does Link 16 can do the same amount of same set of messages, and the same as with VMF or any other MIL standard. So if there are systems that need to talk to each other, they need to have the same requirements for sharing tactical data. And then my last point is GCS Marine Corps in a contested environment. I talked about the challenges of GCS Marine Corps, and it's still not ready to be used in a degraded, denied network environment. All right, next slide. Okay, this is the slide that you all came here for. This is some industry opportunities. MCTSSA is about to award a $150 million ceiling 5-year contract called the MATOC, the Multi-Award Task Order Contract. And Major Fushi will be here tomorrow afternoon to discuss it in more depth. But I'm not a contracting officer or have that much knowledge of contracting. But essentially, it's going to have it's going to be one large contract for a ton of different types of network, cyber, and lab manager services. And from a naval integration perspective, these are just some of the topics that we are going to be looking for industry to help solve. The first one being virtualizing shipboard network architectures. So I mentioned that the MCTSSA lab has a version of Canes. Well, that's just one instantiation of Canes at one given time. Eventually, that hardware is going to be a relic of the past, and we're going to have to, figure out a way to, either replace or buy a new set of network architecture that is representative of what we're trying to accomplish. But the overall end state that we're trying to reach is to virtualize and establish a repository of shipboard networks that we can plug and play depending on, if a program office wants to test on this type of ship and this version of Canes, we can plug and play using that network architecture. And likewise, if a MEU is going to deploy on this ship that has this certain network architecture, we could use virtualization to load that network architecture in our environment and test their C4 systems like they would exactly on the ship. And so if anything, it provides repetition. It provides them a realistic environment before they step on the ship for the first time. If the ship's out to sea for whatever reason, they can plug in the different network architectures that they need. And so it provides a lot of opportunities. And I think the Navy Program Office as well would be interested, PMW 160. I don't know how much virtualization they have been doing, but so there's a lot of future application of this as well. And then not just virtualizing it, but automating it as well. It is a labor-intensive process to build a shipboard network architecture. So leveraging automation tools, such as a solar winds or something of that effect, to automate the network rebuild. That way, if you want to deploy with this network, you already have it built in a lab, and then you can plug it in, and then based on the preset network architecture, it's already built for you. A mobile ship self-defense system suite. We are looking at expanding our CA Afloat and JSF integration testing. Previous testing has pretty much used a black box for the F-35 portion, so we're hoping to get something like a land-based simulation tool, or and then also from the combat system of the ship, a mobile testing suite for SSDS. Emulation of shipboard radio equipment. So our end state is to provide every single asset that Marines would have access to on the ship in our lab. And so we don't have all of the shipboard radio and antenna equipment, but that is something that we are working towards, whether it be purchasing or procuring it through the program office, or if there's a way to emulate that through software-defined radios. But replicating and emulating that capability in a lab experimentation and testing environment is very important. And then lastly, MCTSSA has traditionally done Intel testing for Intel programs of record, but recently, in the past 10 years, that kind of went away, and now we're kind of going back, looking at, hey, how can we incorporate Intel testing? And it's going to require accrediting a SCIF, whether it be using existing infrastructure or creating additional infrastructure through a shelter, but not only for shipboard Intel testing, because we do have a JIC, although it doesn't have the Intel systems within it yet. So shipboard and land-based Intel testing to set up that facility for that. Next slide, please. All right, that's it. This is my contact information. Below is the contact information for our S3 for scheduling or exercise scheduling. And with that, I will open up the floor to any questions.
Yeah, hey, good afternoon. Thank you very much for that. Scott Kinner with McTogg. So listening to everything you talked about, I'm trying to turn what is a statement into a question, right? So looking at the Commandant's plan and guidance, listening to the service chiefs this morning talk about the importance of naval integration, I heard a lot about trying to make sure our systems work in our spaces while their systems work in their spaces. But if I start saying things like, I'm going to have long-range precision fires on key maritime terrain as part of the Composite Warfare Command, that vision has individual Marine things plugged into the Navy's tactical network and answering to a strike commander. So what's the way ahead? I mean, so I know you got the fight you have right in front of you. Every time a MEU shows up, it's a bespoke solution set that it's your job to deliver, so I get that. But from where you're sitting, where are we moving towards a combined COP? I don't need a land track and a maritime track. If I'm supposed to be providing sea control and sea denial to the Navy, I need one track. So where are we headed in that direction? Thanks.
So that's a great question. I don't have the flag officer, decision makers answer for you, but from Major Ackland's perspective, the green and blue divide is starting to deteriorate, and I will start refraining from the use of the terms blue and green and going towards naval instead, because we are a naval force, and that's the way we're going. Most of the systems that Marines use and Navy use are separate systems. There are new systems coming online, like CAC-2S Afloat, which is a repurposed Marine Corps program of record that is being used in blue and green workspaces by Marines and sailors, and it's going to be maintained by the Navy and Marines. So when it talks about blue-green C4 integration, that system is there right now. And the purpose of it is going to is ultimately to leverage F-35 capabilities that were not previously on the ship. And so that system right there is what we're really working towards. Working very closely with IWS-10. But that is a great point. We need to get away from blue and green systems, move towards a naval term, and our system should talk with each other, and everyone should be supporting the same fight. I completely agree. Like I said, there are some systems moving that way, but I think it's a few years off. All right. Thank you for your time.